Hello, this is a quick video on how to do a snow route or landscaping maintenance routes using your phone and using artificial intelligence, in this case Gemini. To do this exercise, I'm going to assume that I have 100 sites, and these are 100 sites that were picked randomly in the Edmonton area. These are actually gas stations that I told the AI to pick just for the sake of this exercise. And I also told the AI that I'm putting 15 minutes on each site, assuming that that's the time that it's going to take to remove the snow or do the landscaping maintenance or anything like that. However, that time could be anything. It could be 5 minutes on one, 10 minutes on the other. I just did this to do this quick, to simplify the process. After I did that, I asked the AI to group the 100 sites into 15 sites. Why? Because, as you might understand, I will actually put the number here, but the problem is extremely complicated if you try to make routes for 100 sites. It's a number that is so huge that probably you will spend your entire life doing that, because there are too many combinations. And all the combinations are valid. So in this case, we're trying to find some of the best that give us the best times, right? Some of the best solutions. So initially, I told the AI to give me what would be the best set of grouping that it would create. So the AI came up that the best optimal grouping would be 6 groups. But I do know that if I'm trying to do routing, to come up with a schedule and have all this, I need to have as many groups as possible. So I told the AI initially to make a set of 20 groups, but it kind of broke. The AI kind of broke and crashed trying to separate this into 20 groups. So eventually I did it into 15. I was able to get it into 15 groups, and it kept working smoothly with 15, so I kept that going. So basically the grouping, the way it's done, is based on the distance between the sites, based on how close they are from each other. The AI will pick automatically those clusters based on how close the sites are to each other. So it divided based on my request, it divided on 15 sites, as you can see here on this image. The other thing that I asked the AI to do was to calculate the centroid of each of these new groups. So I need to have the actual centroid where these are located. So if you see here, you see there is a column for estimated latitude and estimated longitude. So here is a better representation of the 15 site with the centroid. It's worth noting that every time you make these groups, now the total of time spent on each centroid, on each location, is the sum of the gas stations within that centroid, right? So for example, if one centroid has 5 stations, and in every station is 1 minute, so it's 5 minutes on that location. So just to give us an example. And this is actually what you can see here on this table. For example, the groups are numbered from 1 to 15. You can see the site count on each group, and you can see there the multiplication for times the time in hours, because we're allocating 15 minutes for each site. So after that, I told the AI to generate one route for one person to drive around to these 15 places, to these 15 centroids. Take in consideration the time it's going to take at each place, right? And to come up with a time. According to the AI, this would take one person to do all this 29 hours in 45 minutes. So, and that's including, as you see there, 24 hours of visitation and 5 hours of driving. So which is a very interesting thing. So obviously, I'm not going to do this one person. I'm going to actually start telling AI to give me different solutions for these things. So let's see how that goes. So in this case, if it is 30 hours that I have there about, I'm gonna divide that by 5 hours, because I'm gonna imagine my crews doing this in 5 hours. So I'm gonna do this with 6 crews. So in this case, this is the first solution. In this solution is probably the most common situation that most landscaping companies have. So I'm telling the AI to create six routes for me to visit these 15 centroids, departing from a common place, which could be, for example, the shop of that company. In this case, I'm assuming that my shop is the parking lot of Walmart West End, just to pick a random address. So it generated, as you see here, 6 routes based on that. And just to kind of give an example, you can see here that the first route will cover G3, G11. For example, number 3 will cover G10 and G1. And it gives you the value of how much each group is going to spend on visitation, how much in driving time, and how much the total, adding the two numbers, right? So you can see then at the bottom, altogether, they're going to spend 30 hours working. But as you can see, one crew, the number 6, if you see here on the right, it will spend 4.25 hours. So that's the crew that's going to finish the quickest. But there's another crew there that is going to take 5.75 hours. So very interesting. This one here is actually solution number 2. The difference between this solution and solution number 1 is like on this one, instead, I'm telling the AI when the people depart from the main base of operations in Walmart West End, to make sure that each person that departs, each crew, takes the nearest centroid available to prepare the route. This is typically the method that I find the way that I prefer to do it. So, and yeah, that's what this method is about. This one is solution number 3. This is actually a solution that I told the AI to go wild, do whatever you think will be the best solution, and prepare your 6 routes any way you want. And yeah, in essence, if I had told AI from the beginning to do this, to divide the 15 groups between 6 routes, this is what it would have come up. And according to the AI, it did this thinking that this would give the best solution, and actually it wasn't the best solution. And this one is solution number 4. Let me tell you in advance that this was actually the best solution. So in this solution, we're assuming that since there are 6 crews and there are 15 centroids, that each crew will pick 1 centroid each. So that's assuming that as soon as the shift starts, each crew will be already in the centroid of each group, each cluster. So this was actually the quickest solution of the ones that I researched in this exercise. So this was the quickest one. This one is actually solution number 5. In this case, I'm telling the AI to assume or create a new centroid, and this centroid is going to be in the center of the other 15 centroids. So in this case, all the crews are going to depart from that point. It's kind of like you had the option to locate your shop right in the middle of all your places that you have to service. So this is actually a very good solution. This one was actually the second best solution of them all. This is actually solution number 6. In this case, I told the AI to make a new routes, but to try to balance the crews in a way that they all finish, that they all start and finish at the same time, which typically is what you try to do anyways, because you don't want some crews to work for little time and other crews working for a lot of time. So you try to balance the crews. This is actually what this solution does. So, and this at the end is the final comparison of all the solutions that I think of. Again, number 4 was the best. That's the one in which I mentioned each crew will depart each from a centroid. So number 5 was the second best. That's the one that departs from a centroid that is located in the centroid of the other centroids. So kind of like having a central location that is legit, a central location among all your sites, right? So if we go now here to the right here, you will see, for example, that solution number 4. There is one route, number 6, as you can see there, that will take 3.75 hours, and the average time for the cruise in that route is 4.47. And there is one, as you see there on the far right, there is on that solution that is going to work for 5.25 hours. So what that tells you is that this solution will do the job in 5.25 hours, because that's the longest route in that solution. So that's actually a very interesting thing. If we actually go further down to the right, we also see that not only it finishes on 5.25, it's also the total time. If you add the times of all the crews in that particular route, it's 26.80. And if you compare the other ones, you see how the number increases as you go down the list. Something to notice here, like I cannot say with certainty that I found the best solution for this particular problem, because as I'm saying, there are numerous solutions. There are lots of them. Like probably, I would probably put the number here, how many combinations and how many possible solutions you can make between 15 places between six crews. It's going to be a number pretty large. So, but again, these are the ones that I think are more interesting. That this is actually how most people think when they are doing these things. So, and yeah, this is actually a way of how to do this on your phone. And by the way, I'm using right now a Samsung Fold 7, and I'm using Gemini. And yeah, this is actually, I was able to complete this in less than an hour. And before this technology was available, they used to take many hours. So this is a good moment for people that are actually making routes for snow using this technology. The other thing that I would like to add as well, this type of solutions, like as I'm saying, there's no way from the get-go to get a solution and determine that this solution is the best. For you to know that, you need to compare your solution with the other ones and see which solution is the best. Thank you very much.